Well, we have a power function. Form is y equals a x to the p. We want to find out what a and p are, so we'll know what our function is. We have a graph, and this is x, kind of inclusive, but let's write it out. This is x, and this is y. Well, we've got these 2 points, so we put these 2 points into this form, and people did that quite well. Okay? So, and as I just said, we understand that that's a pretty mechanical procedure. You can do it for a form of a quadratic, you can do it for the form of an exponential, you can do it for the form of a power function, you can do it for the form of a linear function. Okay? And it's only those 4. I get it, yeah, you could do a logarithmic function. You can do just about any kind of function. But, okay, so we have that, so we get these 2 equations. The 5 goes in for the y, the 12 goes in for the x, and we get this. 5 goes in for the x, and the 12 goes in for the y, and we get this. Okay? Yeah, I've got to stop reversing things. Okay, that was me. And the 9 goes in for the x, the 50 for the y, and put it in here, we get this. How do we solve this? What's the first step we did last time? How did we start?
Divided by each other.
Yeah, divide one by the other. Now I'll divide the one with the bigger number by the one with the smaller number because that just looks better, but it doesn't matter. You're going to get the right solution either way. So that's not a choice you got to agonize over. Okay, so we get 50 over 12 equals a times 9 to the p divided by a times 5 to the p. Now, okay, that's easy enough. So we'll keep this 50 over 12 could be reduced to 25 over 6, but I'm just going to leave it 50 over 12. We'll take a calculator to it. Okay, it's 4.16 repeating, but there's no point in doing that at this point since we're just doing the algebra with it. Well, we can write this as a over a times 9 to the p over 5 to the p. A over a is 1. 9 to the p over 5 to the p, what's that? Everybody remember from a couple of months ago? We did these. So hopefully I'm just refreshing your memory. That's 9/5 raised to the p. So that okay, what kind of an equation is this? Well, I'm going to tell you what the solution is, and then you'll recognize it. Okay? Solution to this equation is doesn't that make sense? You got a number to a power equals another number. It's an exponential equation because you're trying to solve for what's in the exponent. You simply convert it to a logarithmic equation and then turn your calculator loose on it. Okay? Either that or you get a good graph of the log base 9/5 and make an estimate. You probably don't want to do that, although it wouldn't be too much of a reach to spend a day and learn how. We're not going to do it. Okay? You just do the 9/5 to the x function, invert it, and you got a graph. But right now, from what we've been doing, you know how to solve this equation. Okay, convert it to log form. Okay? And then the P pops out as your solution. Okay, well, let's see. Yeah, 9/5 is pretty close to 2, isn't it? That's almost a log 2 function. And 50/12 is a little more than 4. Okay? And the log base 2 of 4 is 2, right? That's a little more than 2, and this is a little less than 2, so it's a log to a smaller power, or smaller base. So I'm gonna bet that that's not much more than 4. I'd say, I'm guessing. And that's hard to estimate. Okay? I mean, there are things I could do. I'd probably have to write stuff down, and that still wouldn't be all that accurate. So somebody take a calculator and see what that is.